In 1964, the space race was in full swing. The Soviet Union had beaten the United States not just into space, but into orbit. But after the young President Kennedy stated that we would put man on the moon before the end of the decade, NASA pushed full speed ahead towards the moon.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
When Kennedy made his 1962 speech at Rice University, the Mercury program had one flight left before it came to a close. And as much as anyone might have wanted to jump right into planning for Apollo, there was a significant amount that we did not know about space. For one, could a human survive the week-long journey to and from the moon? Once we landed on the surface, how would we return? How could we control and power the spacecraft? Mercury, while it had brought American astronauts into space, was just scratching the surface of what a spacecraft could be. The technology equipped was rudimentary compared to later spacecraft. Instead of a computer, many of the systems were controlled electromechanically, similar to the operation of some airplanes. To get to the moon, we needed more. We needed better maneuverability in space, and we needed an onboard computer to control the spacecraft. Thus, Gemini was born. The two-man missions would be a true test of the necessary requirements for lunar missions. They would test newborn computers, docking mechanisms, life support, and human endurance. The first mission of the Gemini program would not have a crew aboard. Instead, Gemini Titan 1 would test the Gemini spacecraft and the Titan booster. Originally designed as an intercontinental ballistic missile, NASA placed a manned spacecraft instead of a nuclear warhead atop the Titan. And on April 8, 1964, the missile-turned rocket ignited the Gemini program and proved itself capable of supporting manned spaceflight.